That sounds like a Scottish robot.
Dude. Is this it? Are we ready?
Ready. It's good.
Is Jared remoting in for this? Or?
No remote today.
No way to remote and record and do everything we need to. So it is being recorded though. Because Jared can watch it later.
Oh, I can set. All right. So,
What are you drinking?
we're not we're going to talk about data warehousing and Bloc. You guys probably already know what this is, but I wanted to reuse this slide from all hands presentation because it's funny. So, yeah, basically the data warehouse is kind of a lot like San Francisco. We got our Rails app and like Potrero, Soma. We got Marketo marketing stuff like downtown, and then sales up in the arena. And the only way you get all these people together is you have a data warehouse party in Oakland, and you get there on the ETL tournament. So yeah, basically what we'll do is we'll go over a couple definitions to kind of explain why we do things the way we do it, and then we'll look at some code, and then hopefully, because I'm not really sure what all you guys know and don't know, want to know, so hopefully we'll just do some questions at the end, and we can look at code. It's useful. So basically our stuff is split up into facts and dimensions, so let's figure out what that is first. First, dimensions. Dimensions table consists mainly of descriptive attributes that are textual fields. So a good way to think of this is a dimension is something that exists outside of the business process. So it's like a time or a date, or a person, or it's a thing that has stuff done to it. And so this part is really important. The descriptive textual fields. That means that dimensions, we don't want to have dimensions reference other dimensions or facts or anything. They're just a single descriptive attribute. So for example, a lot of times you would think like a timestamp is something that you would associate with like with a dimension, but that is actually a separate dimension. So, and we'll see when we talk about facts.
Really,
how you bring those two things together.
Like why is it
What?
that way? Like why is it just only textual?
Well, I'll explain.
Okay.
So, so facts is a table that mainly consists of business facts and foreign keys that refer to primary keys in the dimension table. So basically, this just means fact tables are mostly just a collection of dimensions. So, and they usually describe a business process. So they describe an event. And so events are, just an assembly of these dimensions that are things that have things happen to them. So, for example, like so let me get ahead of myself. The next thing, this is kind of how we lay everything out. It's called the star schema. And so this is actually a pretty good example here, where this is your fact. In this case, I guess this would be like maybe like a sale or something. So you've got like the profit and number of sales, and then associated with each entry here is a customer, a product, a region, and time. And this is really nice for a couple of reasons. One, it keeps dimensionality low, so there's only like one. Basically, you've got this one hub that everything kind of sticks to. So your joins are very simple. It's always just you're joining primary key to foreign key, or foreign key to primary key from your fact to your dimension. The other thing is that we'll see when we go through the code in a little bit. Arranging things like this also reduces dependencies. So basically, none of your dimensions are dependent on other dimensions, which means you can run all your dimensions in parallel when you are running the ETL process. And then fact tables only depend on dimensions. So once you run all your dimensions and you have those, then you can also run all the fact tables in parallel. because they also don't have any dependencies that need to be resolved. So there's other ways to do this, but we found that sticking to this star schema is keeps things fast and keeps them very simple as well. You'll see like the code for the fact tables is basically just a list of foreign keys for dimensions.
And there's nothing where like product has a region?
A product only has a region when it's involved involved in an event, right? So like a product is something that just exists on its own. The region that, if we're calling this a sale, then this would be the region that it's sold in. And maybe if like the product was manufactured in a different region, then that would be like your production fact table or something like that, where you could collect all these things together.
So it kind of like tells a story. It's like
Right.
the amount of products bought by this customer, by in this region, by this year, by in this month,
Right.
like total sales.
And the thing about the star schema that's very counterintuitive when you're used to building like apps the way that we build it with a relational, like object-oriented database is like there you're trying to reduce redundancy, right? So it's like if you got some region, you want to like reuse that for everything. So you've got lots of foreign keys pointing all over the place. In the data warehouse, since we only run it once an hour, we don't really care about, and we've got plenty of space, we don't really care about, we care more about efficiency of lookup. So redundant records and like, even if you have a fact table that's almost completely identical to another fact table, rather you want to actually, and this is hard to get through your head, but it's like you want to actually repeat all these fields rather than referencing another fact table. Because one, it makes it more complicated. It also means that your reports might get messed up if you change the one fact table. It also then introduces this dependency tree where you need to make sure that you're running the dependent fact table after you run the first ones. But if you do it this way, which is cool. So
Are there
no,
are there abstractions that, or I guess, are there situations in which organizing a production database like this makes sense, or is it mostly like you said? You made it sound like it was more efficient, or like having things relational in that way. It makes it sound like it's like for productivity's purpose. But if you maybe had an abstraction that made a more productive interface for this, are there cases in which this makes sense to kind of architect a database in this way?
Maybe not exactly like the star schema, but definitely a lot of companies that are write heavy or read heavy rather than write heavy will have I always get denormalized and normalized.
It's the opposite of what you think it is.
Yeah, so I'm not even going to say it, but they'll basically have redundant data where you basically write information into the database in the format that you want to read it out. So that way you have like basically like a constant time read rather than having to like go get all these things, join them together, and then hand it off.
Yeah.
So I think like a lot of like scalable, massively like scalable websites with some just
The needs of an operational system in a very small scale product mimic the needs of reporting. So you start out with enrollments. How many enrollments did we get last month? We have one product with one mentor thing. You can't switch mentors. You can't upgrade. You can't do doing that. So the system you need to operate the product is the same. It's easy and simple to get data out in the same way that you put it in. But over time, as the operational system becomes more complex, the questions that you ask of the operational system diverge from the questions you ask from a reporting perspective,
right.
which is the primary reason you have a split between needs and rights.
Well, and also if you're trying to like build something that's both scalable and kind of and also malleable to your changing business needs, your reporting is always going to correspond to your kind of business model.
Yeah.
Whereas, as we've seen, very unfortunately, like building a business model like really deeply into your data model is kind of ties your hands a little bit in the future if you're trying to do things like
Thanks.
that. So
That's an excellent point.
let's
Before jumping into the code, and feel free to just push me back, will we have time maybe at the end to go through like examples of when do you have a dimension that has if I'm thinking like freezes, like when do you have a freeze dimension that's one per user and then another one that's just every single freeze, or like
those would be fact tables, because a freeze is like a thing,
okay.
and a freeze happens to a user, so you can collect those in a fact table. So you can, and that's why those entities exist, so that you can slice them up in different ways. You can say, show this to me by user. You can say, just show me all the freezes that exist.
And each of those would have its own fact table.
Yeah. So it's very redundant. That's kind of what it's optimized for.
Like you build one fact table for the query, basically.
So you'll see the code here is pretty. It's pretty simple for the most part. It's basically just a bunch of Ruby, like plain Ruby files and classes that are kind of glued together with some scripts. So the two main things here are these two. There's the ETL directory and the script directory. So we'll go through the ETL and then we'll go through kind of how it gets run with the scripts. So this is the ETL base class, which is this is the parent class of both the fact and dimension class, and it's pretty straightforward. Basically, you initialize it with a database. There's got some things for creating and dropping tables, and then these are the three methods that you generally override. They've got some default behavior: extract, transform, load, which is what ETL stands for. So extract's going to pull some stuff out of the database and return an array of records. Transform is going to do whatever cleaning or moving around or finding things you need to do. And then load sticks it into the table. There's a couple other methods here. Find by, get. These are just for like looking up things, finding records on a class. So basically, when you want to start writing a feature, you usually start with a query. Now, Jared actually wrote a really awesome generator, a lot like the Rails generators, that you can say generate a fact or generate a dimension, and it'll spit out the query file and the correct files in here, and a couple other things. So that's pretty cool. So let's start with a query. Queries are use some Ruby metaprogramming magic. So what this does is this will basically iterate through the queries directory, and right now we interact with two different databases, the Salesforce database and our actual like Bloc product database. So this goes through both of those directories and automatically generates a class for those. So if you can see it in a comment. If you have a file, if you create a file that's ETL queries block foods.sql, then it creates this corresponding class that's kind of camel case like, or named similar to how like Rails will name things. So the cool thing there is you can write like pure queries, and then, but then as we'll see when we look at the facts and dimension classes, you just use them like Ruby objects. So they basically all have a query method on them. So there's just a class that has a single method called query. So there's a subclass for Bloc and there's a subclass for the Salesforce database. So we'll look at, so this is to get all the roadmaps. It's as simple as this. You just select a couple of these fields from the roadmaps table in the Bloc database. And then we can look at the roadmap dimension. So the extract, query gets called under its underlying method, but fetch is the public method. So here you just override extract. All it does is just call fetch on this query class. And transform, you can see, just iterates over all the records that get returned from extract. And it maps these to objects that are going to be the actual names of the columns that we have in the data warehouse database. A lot of times they correspond to the name in the Bloc database, but not all the time. We try to keep things like a little. Once again, we're addressing like the business cases rather than the development cases. So we try to use names that make sense to people that are thinking about things in that way, not thinking about databases or Ruby or whatever it is. And then load, also pretty simple. It basically inserts. So a principle that we try to follow is we try to not have any null values in the database, in the data warehouse. That's because a null value is, as we know from programming, like kind of evil because it can mean a lot of things. It can mean the thing doesn't exist. It can mean that you didn't find it. There's lots of different things. So you can imagine like if you see a student, you're looking at the student roster and you see the student has a null value for the mentor. Well, does that mean that like we just couldn't find that mentor? Like maybe something got messed up. Does it mean that the student really doesn't have a mentor? Yeah. So this kind of disambiguates that where so for this we'll just have an unknown record. So when you call that find by method, if it can't find anything, it'll automatically return this unknown record. But there's when we look at mentor, there's actually two of these null records. There's unknown and then there's known.
Take it, you saw it, you wrote original ref uncount.
What's up?
The third unknown is uncount.
Oh yeah. Are you guys not familiar with that word?
It's like
This line's
It's like
like
an
unknown, right?
It's Latin for unknown, yeah. Reese said. That's probably Jared.
Blame it.
Boom. Yeah, and then this one also over. So the find by method provides you a bunch of different ways that you can modify it if like it's not just a straight lookup on a field. So this also overrides that. It's not that important. So then this is what a fact table looks like. So here you can see we're doing a couple queries. So this will pull in a bunch of different stuff that we need. It will then, it has a little bit more of a complicated transform step to where it needs to do some like lookups, it needs to do some parsing on things, and then here you'll see this is kind of the big meat of almost all fact tables look like this, where unfortunately I haven't figured out a way to make this syntax not so long, but it does this, uses this class method to find the corresponding records. So we'll look up things based on their original ID or their ref or whatever, and then so these are all the find by method returns the key of the corresponding dimension. So these are all foreign keys. Oh, and actually, let me go back to I forgot to mention one really important part of this. Every fact and dimension table also has this schema method that you have to define, and this is using SQL, and it's kind of similar to like a Rails migration. The nice thing here is we don't need to do migrations because we blow away the whole table and regenerate it every hour. So if you make updates to the schema, the next time the ETL runs, it blows that away and then does everything from scratch, and then it spits out a schema file, kind of similar to the way Rails does.
So did I hear correctly that these files, these roadmap RB and student roster RB, are like dynamically generated using metaprogramming?
Not these.
Oh.
This thing up here, so like this guy, like this class, like a source file for this class does not exist. There's a file in the ETL queries block directory called roadmaps.sql.
Oh.
And so this class just gets, rather than having to like get the file, parse it, like execute the code inside of it, this just does all that automatically.
This is the dimension class, not the query class that we're looking at right now.
Yeah, got it.
That makes sense.
So yeah, so then same thing here. As you can see, these are all just keys that reference these other dimensions. So how the hell does all of this do anything? It's all so it all basically runs through this kind of master script called BI. So you run this by doing just script BI, and it kind of works like Rake, where you can define different tasks, and then the BI command will basically make sure that it can do things depending on your environment. It sets up all your environment variables to make sure that like everything's running with the correct environment, and then it runs the command. So it's pretty simple. What this line is doing is just it splits out the commands like directories. So you can define any command you want in this command directory. So for example, and then any subdirectory is separated by a colon, kind of like how you do like rake colon db or rake db colon migrate. Here you can do like bi db colon create, and it will just try to find an executable script here and run that for the correct environment. So the biggest one, kind of the master script here is the ETL script. So this initializes with some stuff. Yes.
What does BI stand for?
Oh, business intelligence. Maybe not the greatest name, but it's the name of the repository. So stuff like that. So yeah, sets up some logging, connects to the database, grabs all the sorted fact and dimension classes. It will go through and it gets all the table names, blah blah blah. It does some cleanup. Not that important. We got this thing defined here where you can, if you define these guys in dev, you can skip different fact and dimension tables, so you can do debugging faster. You don't have to run the whole thing. But the real meat is here in the run method. So do some logging, drop all the tables, drop tables that are totally dead, create new ones, and then calls this ETL method on facts and dimensions. So we can look at that. It's also pretty simple. So you pass in all the fact and dimension models. It uses this magical PMAP method, which we'll look at in a second. And then it basically just goes through, creates the table, calls extract, passes the result of that to transform, passes the result of that to load, and then you're done. And at the end it dumps out the schema to the schema file. So the cool thing about this, so when we first started this, we were basically just running this all sequentially, and it started to be really slow. So there's a couple different things you can do there. You can rewrite the whole thing in some other language that's faster. You can try to offload more stuff to the database. What we decided to do was to, since we have this star schema that provides us this nice ability to parallelize things, was to parallelize it. So the issue, man, I should have done a slide on this. I kind of forgot. This is a little more involved. But basically, Ruby doesn't have real threads. So it runs under this thing called the global interpreter lock. So even when you have threads in Ruby, it still can only actually run one process at a time. So it can give you the illusion sometimes that you're running in parallel, but you never actually are. And if you look at like the performance on a multi-core machine, it'll only peg one processor. So you can you're basically just wasting all those extra cores. So we switched over to JRuby, which was actually pretty painless. JRuby runs on the JVM, which is the Java virtual machine, which has real threads. So we can actually do cool stuff like, we've got a core extension on the enumerable class. So PMAP basically just takes a collection. It's going to slice it up into the number of slices that you pass as a thread count. Defaults to, you can either set environment variable or defaults to 8. And then it basically just slices up whatever collection into that many pieces, and then it runs that in parallel. So if you have 8 threads, it's going to split, like basically divide your thing up into 8 equal sized pieces and run each of those on a separate thread at the same time. And then it returns, it then flat maps and returns the aggregate result back to you. So we saw like a pretty significant, probably like, I think ETL went from taking over an hour to now runs in like 23, 24 minutes. And the cool thing about this too is that you're basically only blocked. It doesn't grow linearly as you add more facts and dimensions. That time only really increases when you add a longer running. So it's basically going to run all the dimensions, then all the facts. And as long as you don't add some super long running process there, it pretty much can scale out pretty far. So sorry I didn't have more slides about that.
For the what part of this is unique to JRuby? Is any of the language different between JRuby and regular Ruby? Or is it just the implementation?
It's just implementation. Yeah, there are, so you can do things. You can do all kinds of crazy stuff with JRuby. Like you can actually like wrap and execute Java classes. You can access like underlying primitives that are provided to you by the JVM. But the only thing we're using here is just the actual like Ruby thread, which under the hood maps to the Java thread class.
Okay. This could run in regular Ruby, but it wouldn't be true multi-threading.
Yeah, the only thing that would make this code not run flawlessly if you just switched Ruby versions is some of the gems that we use, like I think actually only the debugger and the database connection module. Those gems are different because they actually have to compile native Java code to work. So basically swap out 2 lines in the gem file, switch your Ruby version, and all this would run just way slower. So then, only other part is how this thing is deployed. So we do basically like, you could probably call it continuous deployment. Basically, whenever something gets pushed to GitHub, the next time, there's a cron job that runs on this server. It's just a DigitalOcean server that's at this address. There's a cron job that runs every hour on there that executes some stuff in that scripts directory in the repositories. So it pulls the latest code, then it'll run the ETL. That spits everything out to a local database. When that's all finished, it uploads the dump of that database to S3, and then it triggers a restore on this is actually running on a Bloc Alpha app. It's just another instance of Heroku Postgres. So it triggers a sync that pulls down the file from S3 and then syncs the database. So that's happening every hour, and we don't have to deploy or anything. Basically, just once it goes out to GitHub within the next hour, it's going to get on. A lot of this stuff, some of it in more detail, is on the README in the repository there. And that's all.
You wish.
I have a question, or a request actually.
Mhm.
One of the most valuable reasons to have a process like this at all is something that you mentioned that I think is worth reiterating, and that is converting the way that we talk and the words that we use on the engineering team to words that other people outside of the engineering team use,
Yeah.
even though they may mean the same thing. And that often happens in the transform step. But oftentimes, or sometimes, you have to not just transform what you say, but you have to reconcile. So I'm curious if you could show the student dimension,
Yes.
or some other dimension that.
I
A common question might be, show me the student roster, but show me who's student advisor.
There's
And that's
yeah.
not a
So there's
question you can answer by looking at our block database. You have to talk to Salesforce.
Right.
there's a couple interesting ones. I think. Let's see here.
Choose whichever one you think is.
I think program is pretty interesting. So program. So we call these. I mean, we call them courses in Bloc, but we call them something different in Salesforce. So we don't. In this case, we don't actually pull those from Salesforce because they're not actually like stored directly in the table anywhere. We probably could do that, but it's usually easier to just we manually keep this mapping up to date. But this is what we call the different courses in Salesforce, and so then we actually store both of these labels. And so then in the student roster, yeah, so in this case you can see program key is looking it up on original course kind. But if we look at something like if we look at leads, where this has a program, it's going to look it up by the Salesforce label because leads is all from Salesforce. So we have to reconcile like how these two things that are kind of disparate in our two separate systems are correlated, and that happens right here. So like when we launch a new program, we have to update, we have to both we're pulling the new course kinds from our product database, and then we have to also go in and map it to the correct Salesforce one. Because we only have one program. It's not like we have a Salesforce program and Bloc application program, because hopefully people shouldn't have to think about that. They should just think you enroll in a program, and it doesn't matter if we're talking about leads or we're talking about a student model that exists in the Bloc database. We just care about the business case, which is that they're enrolled in a program. Is that answer? I think there's some other.
I think a reconciliation example in the student dimension would be good because it shows how you have to select a key and literally say that this student is represented by their email address.
Right.
And you can pull different information from both databases and store them together. Like who their owner ID is. In Salesforce, owner ID is what we call student advisors.
Yeah.
We call it student advisor in the data warehouse because that's the one that use Salesforce owner.
Right. Yeah. So this is gonna take the Bloc record. It's gonna reconcile the email of the student with the Salesforce record. And then that gets used. It doesn't actually use it. Is that a public record? Or fine? Sorry.
I think it's the first line in the transform. Or no, sorry.
Oh right, yeah. So we iterate over all the block records, and then we find the corresponding Salesforce stuff, and then this is kind of a mix. The actual student dimension is a mix of information from both Salesforce and our database.
This is so powerful. It may not be obvious to everybody here, but when someone asks, I want to see who's that student advisor? Behind the scenes as an engineer, it's very tempting to say, shit, well, I gotta go look. I don't know how to plug our application into Salesforce. No, you can just look it up in the data warehouse because you reconcile these things.
Right. Yeah, because there is actually no connection between like the sales. This is the only actual direct connection that exists between a student advisor and a student in our system.
We don't store that in our database then. So
No, because all
interesting.
the interaction happens in Salesforce, and so the email address is kind of the only point that
It's like the key.
yeah, it's the
segregation.
key, yeah, it's the primary key for those two things.
That's cool.
Any other questions?
Can you show what the connection between facts and dimensions are in Looker itself?
Yeah. So yeah, Looker is probably like an entire other talk. But so this is primarily the way that we interact with this stuff. If you go into the Explorer here, these mostly the Explorers all Looker has its own window, but you can basically think of Explore as fact tables. So if we want to look at like what was the thing we were just looking at? Weeds. We can come in here, and then you can see that there's all of these dimensions in here that you can then select attributes from. So this is, once again, very confusing because they have their different lingo, but this is actually, in data warehouse lingo, this is the student dimension, and then these are all the different attributes in the student dimension.
The dimension is just like another table, right?
Yeah,
The fact table is just
it's
connected to-
referencing.
Yeah.
It's referencing a specific entry in that.
And
Same
they
with
call them dimensions, but they're actually, well,
attributes on dimensions.
right.
Yeah, it's a little weird.
I suspect they do that on purpose for some reason.
To troll people.
Yeah.
Boost their perceived
Social.
value.
Is there a way to not have a fact table exist in the ETL, but to only have that fact be in Looker? That makes sense?
Yeah, I mean you can use Looker. Looker right now only hooks up to our data warehouse, so everything that goes in here has to go through the ETL. We decided to do it that way basically so that if Looker gets too expensive or goes under or whatever, we can just slap something new. There's a billion of these companies popping up now that we can slap something new on the top, and it wouldn't be that much work to get back to it. But Looker is actually powerful enough that you can theoretically not have an ETL process and do all the joins and all the reconciliation and all that stuff in Looker. But then you're like totally bought into the Looker way of doing things.
The other thing is, we didn't have Looker when we began, either. We were just writing SQL statements into data clips and then exporting data clips into Google Sheets and then generating visualizations in Google Sheets, and that worked really well actually. And it meant that we developed a discipline for, as an engineering team, so to speak, having an understanding of what the cost is whenever we spin up a new disparate system. We have to reconcile things. We have to make sure that we are consistent in how we name things. And you can see, you can still do that today if you want to write SQL. Maybe it's worth showing after you're finished is point and click and see how kind of what the data warehouse does is, or what the YAML does in Looker is construct this UI based on the columns and the names of our tables so that users don't have to write SQL. You can see the generated SQL that it
Yeah,
was
right.
based on that.
Well, another good way to see it is, so Looker has this like proprietary format called LookML. It's like, it looks a lot like YAML. But you can see here, this is where we basically create these explores. So this is just saying, look at the charge facts table, give it this label over here, and then you just list. And like, it felt pretty good when we like did this like consulting thing with, we like paid for some consulting hours with a Looker engineer, and they like came in and looked at this and they're like, oh, well, you guys like already did all the work basically. So like, because you can do all kinds of complicated shit in here, but ours is like totally flat because it's just like, it's using that star schema, right? It's like, here's the thing in the middle, and then here's all the little points on the star, and it joins all of them. Now some of the stuff you can see can get a little more complicated where you can like add SQL. There's other cool stuff you can do. I'm trying to think of a good one to do it. You can do some interesting stuff where you can like add different calculated fields onto the dimensions. But for the most part here, it's just mapping tables to this point and click interface.
Customer loyalty does it. Customer loyalty calculates NPS.
Oh yeah, good call. And here, this is describing a dimension table, and it basically just is doing type definitions for telling Looker how to format this information.
Can't Looker just look at the database and then type?
That's a good question.
It does.
I mean, it does, and it has like default behavior based on that. Yeah, I'm not actually sure. These actually get generated. You can just generate them from the table, and that's usually what we do. Sometimes we'll have to go in and change things, but for the most part, it generates you can generate a new model or view based on a table in the database.
So we can't calculate the NPS score. As a reminder, is the the percentage of promoters minus the percentage of detractors. So you get anywhere between 0 and 100 at all times. But we can't do that in the ETL, or it's difficult or costly to do in the ETL. But what we can do is mark each NPS submission as a promoter, a neutral, or a detractor, and then
Just count them up.
you can count up and do some tracking ourselves. That's like a really simple thing.
Now, is the correct way to probably have that all done in the ATL?
Yes.
Which we could do. We do other aggregate things other places, but
It's just like the amount of fact tables that have to be created is pretty massive.
no, this actually wouldn't add any more fact tables. This would just be a field on the fact table. There's just never been any. I think early on, somebody, I'm not sure who it was, somebody put this together.
Favorite, I think.
Yeah, there hasn't been a compelling reason to.
Wait, this?
Was this
I
you?
did that.
Okay. Yeah.
The other thing is worth noting is it's okay to have a ton of fact tables. Fact tables are not expensive.
Yeah.
Most of the work
And they're
is in
easy
the
to generate.
dimensions. Yeah. Dimensions, once you have the dimensions, hooking up new facts to the existing dimensions is cheap.
Yeah, you basically just list the fields you want, and you're done.
So, like, Levi and me both already feel pretty comfortable messing around with this LookML or whatever. Would you think eventually we should even be a step higher, or we're like throwing together a fact table, or that's not probably not the case?
I mean,
You
I
can.
don't see why not.
Yeah.
There's, I mean, especially with the like kind of boilerplate plate generator stuff that Jared built, it should be easy.
The difficult.
And I video conferenced with Levi a long time ago and walked him through all this code. So I mean, he's seen it. He's seen the exact same stuff, probably actually more in depth than I just showed you guys.
In my opinion, the thing that requires the least mental discipline is it is important to understand why the facts and dimensions are organized the way they are. It's very tempting if you don't have a solid understanding of it. It's very tempting, and we've done this actually in the past, it's very tempting to just start joining random things together. When you do that, you actually compromise the integrity of the system, because the integrity of the system rests on the idea that this one thing means this one thing and it's defined right there. And as soon as you introduce another one by joining two things together, you've defeated the purpose of having a data warehouse at all.
By things, you mean fact tables.
Any tables, yeah. So for example, we have a master table that is, the reason that someone wanted a master table is a valid reason, but the solution was not to create a new master table. The solution was to think about what question they were asking. Are they asking about churn? Are they asking about a roster of students? Are they asking about consolidating leads with students? Are they asking? So having a disciplined approach to understanding, like, this question should be mapped to a fact table. Let's just make a new fact table. Join a bunch of things together. If it doesn't make sense, we add new dimensions. You know, maybe some of the dimension connections don't make sense. That's really important. I've seen time and time again, it's very tempting for end users to omit that step. And it's okay if it's all in Looker, you're iterating rapidly and prototyping, but when you add it to the ETL, that's very important. Take a
Because,
disciplined approach.
for example, let's say you have two fact tables that both have users. Like one of them could be like one is like freezes, and then the other one's student roster. You say like, oh, cool, I like want to see all the student roster information along with the freeze information. I'll just join the student roster thing to the freeze table based on user, because that's the way that they overlap. The problem is the student, the granularity of the student roster is actually not student, it's enrollment chain. So when you join freezes to it on users, you get freezes that aren't actually like freezes that don't belong to that enrollment chain, but they look like they do because you're joining on the wrong granularity of the field. And so that's when stuff gets really confusing, because it's like, wait, hold on, like, why does this person have 20 freezes or whatever? Like, I can look right here and see they only have 10. Well, it's because they're getting double counted because they're joining
Enrollment.
students.
It's not an engineer who's confused, it's Amanda or Clint, because they're looking at the support as the source of truth.
Yeah, we should just rename it from master to like Chernobyl or something.
I mean, almost every report I have is on master.
Yeah. There's probably a lot of things that are wrong with those reports.
This is super cool, man. Thanks for sharing.
Yeah. So
I gotta get
Just-
So,
Did Jared leave us?
Yeah, he said he had to go.
This is You're Not Vice is so good. Yeah.